Next is example 19.2 is nozzle flow meter. Ethyl alcohol flow through a pipe diameter of the 60 millimeter. In a finally, the pressure drop across the nozzle meter used to measure the flow rate. Okay, is delta P is 4 kilopascal when the flow rate is 0.003 cubic meter per second, or about 3 liters per second. Determine the diameter D of the nozzle. Okay, that is the diameter D of the nozzle, and given the diameter of the pipe, delta P, okay, and Q, phi D. Okay, this is delta P. From the table of the fluid property, we found that for the ethyl alcohol, the density of the alcohol is about 489, and for the dynamic viscosity is about 1.110 power 3. Okay, this is Reynolds number and velocity and area. So we can find first. We have to find Reynolds number first to get the coefficient, the via coefficient, nozzle, to find the coefficient for the nozzle. So okay. So what is the Reynolds number? Equal to, we substitute another, should have another, this equation should be rho, okay, mu. So okay, we substitute V in this equation. V is equal to Q, area divided by area, mu. Okay, next we substitute area in this equation. Rho Q the cancel, and so we got the number is equal to 4 rho Q divided by pi mu D. Next we substitute number in this equation. Is density of alcohol, is flow rate, and for viscosity, and for the diameter. Okay, so the number is about 42,000. Okay, and from equation of Q is equal to coefficient Cn times An. Divided B is over 4. And we substitute Q is equal to 0.235, and Cn is unknown, and diameter is d square, I think. For different pressure is 10 kilopascal. Okay, and we can reduce to this number. Cn to be Cn small n. Okay, so in this case, B beta is equal to the small d divided by d, equal to d is unknown divided by diameter of the pipe. So we have two unknown. Cn we don't know, and d, so we can't. So this equation we have to assume, using a trial and error, assume that, let's say Cn equal to 1, and you can estimate D. The next we assume further to assume that b subtract b power 4 is about to 1. So we can guess that d is about 0.0346 meter. So what is the, we can estimate beta. Is equal to 0.577. Then the next we do again from the figure 19.11. The number is equal to 22,000. So that is above this figure. That is about this 3. This point 4.2. So and for beta is about 0.6. Okay, so we can read that it's about should be come closer again, check again. Should be somewhere this point because it's a log scale. It should be about this. Okay, so you got about 0.97. Okay. This one we can read from the curve Cn is about 0.972. The next we assume that B is we can find D again. Okay, D is about 0.03341. So that is good enough that we can find B beta again, almost the previous one. And check again for the number is about 42,000 and finally we got D is 34.1 millimeter. I think for this one is about 9.7. It should be come closer to, because of this log scale, it should be somewhere at this point. Yes, it should be. Okay, more than about half of between 0.6 to 0.8. Okay.